Welcome to our channel. Today, we're back with a brand new topic just for you. Before we start the podcast, please don't forget to subscribe to our channel and hit the like button. Enjoy the show.
Welcome to the deep dive. Today, we're going to really dig into the Go programming language. You probably know it as Golang. You've likely heard its name, maybe buzzing around, especially when people start talking about cloud infrastructure.
Yeah, it comes up a lot there.
So our mission, really, for this deep dive is to figure out why Go has become so significant, particularly in cloud-native stuff. What makes it stand out? We're drawing our insight today from an excerpt, a really interesting one, from Exploring Golang, Power, Simplicity, and Concurrency over at Code Talk. Ready to jump in?
Absolutely.
Yeah.
And a great place to start, I think, is looking back at Google, maybe around 2007.
Okay.
They had this pretty big challenge. They were trying to manage these huge, really complex code bases. Think C++, Java, massive scale.
Right, I can imagine years and years of code building up.
Exactly. And they really needed a language that could give them, well, the speed of C, let's say.
Raw performance.
Yeah, but also the readability, maybe something closer to Python. And critically, it needed really strong support for concurrency, handling lots of things at once.
Okay, so it wasn't just like an academic exercise. They had a real practical problem. Scale, complexity, the existing tools weren't quite cutting it in that environment.
That's spot on. And that's really the context for Robert Griesmer, Rob Pike, and Ken Thompson stepping in.
The Go designers.
The creators, yeah. They set out to build Go specifically for those kinds of modern problems. Focus on simplicity, clarity, performance, right from the start.
And it went public in 2009, wasn't it?
2009, that's right.
So, okay, beyond the origin story, fundamentally, what is Go? What are its defining traits?
Okay, at its core, Go is statically typed and compiled.
Let's break that down. Statically typed.
Means the compiler checks your variable types before you even run the code, catches errors early, saves headaches down the line.
Right. Less runtime surprises, and compiled.
It translates directly into machine code, so it runs really fast. Very efficient execution.
Gotcha. Fast. Okay. What else?
It's also built from the ground up, really, for concurrency.
Handling many tasks simultaneously.
Exactly. Very efficiently. And it has automatic memory management garbage collection.
So developers don't have to manually track all the memory allocation and deallocation.
Correct. It simplifies things quite a bit. Takes that burden off.
Okay. So, static typing, compiled for speed, built for concurrency, automatic memory management. That's a solid list. The source also mentions minimalistic syntax. Why is that such a key feature?
Well, that minimalism is very intentional. It's about cutting down on, language bloat.
Bloat, meaning too many ways to do the same thing, too many complex features.
Sort of, yeah. The goal is to make the code just easier to read, easier to write, easier to understand.
Probably helps with team collaboration and maintenance, I'd guess.
Hugely. Makes it simpler for new folks to get up to speed and for teams to maintain code bases long-term without as much confusion.
So simplicity isn't just a preference. It's baked into the design philosophy. But the source also says Go packs a punch, despite this simplicity. How does it do both?
Yeah, that's where it gets really interesting. It achieves power in a few key ways. First, and maybe foremost, is that built-in concurrency support. Goroutines and channels.
Okay. Goroutines, what are those exactly?
Think of them like incredibly lightweight functions that can run concurrently, almost like mini threads, but much, much cheaper to create and manage.
Cheaper how? Less overhead.
Way less overhead than traditional OS threads. The Go runtime manages them super efficiently. You can literally spin up thousands, even hundreds of thousands, without grinding things to a halt.
Wow, okay. That sounds perfect for cloud applications handling tons of requests.
Exactly. It's a game changer for that kind of workload. And channels are how these goroutines communicate safely.
Like communication pipelines.
Yeah, pretty much. Like typed pipes that ensure data is passed between goroutines without causing race conditions or other common concurrency bugs. It provides structure.
Okay. Lightweight concurrent functions, safe communication pipes. That makes the concurrency aspect much clearer. What else gives it power?
Well, secondly, there's the standard library. It's surprisingly robust.
Meaning
it comes with a lot of useful stuff built right in.
Yeah.
Batteries included, as they say.
Like what, for example?
Things for building web servers, handling cryptography, working with JSON, network programming. A lot of core functionality is just there. You don't always need to immediately reach for third-party packages for the basics.
Right, which can simplify dependency management.
Definitely. And finally, as we said, it compiles straight to native machine code. That results in genuinely impressive performance, often getting close to languages like C or C++ often.
So simple syntax, easy to work with, but still really fast under the hood. Okay, that naturally leads to, why do developers actually like it? Why embrace it?
Well, several big reasons come up again and again. That simplicity and readability we talked about.
Huge draw.
Easier to learn, easier to maintain code. Exactly. And initially, it didn't have complex things like generics or traditional class inheritance, which, while sometimes limiting, also kept the language surface area small and consistent.
Fewer concepts to master up front.
Right. Then there's the speed, both compilation speed and execution speed.
Ah, fast builds are always nice for developers.
Oh, yeah. Developers love how quickly Go code builds, and the resulting binaries are typically small and run very efficiently with minimal runtime overhead.
Okay, simplicity, speed. What else?
The built-in concurrency, again, goroutines make writing concurrent code much more approachable than in many other languages.
Less complex than managing threads manually.
Much less complex, generally. And the tooling is another big plus.
Tooling.
Yeah, Go comes with excellent built-in tools. Formatting, Golang, testing, profiling, building. It's all integrated and works really well out of the box. Creates a very consistent development experience.
Standardized tooling helps everyone stay on the same page.
For sure. And we mentioned the standard library having lots of essential stuff ready to go is a major convenience.
Reduces the need to hunt for external libraries for common tasks.
And lastly, cross-platform support is really strong.
Meaning you can compile it for Windows, Mac, Linux.
Easily. And different architectures like ARM. Cross-compilation is usually just a matter of setting a couple of environment variables. Makes distributing tools incredibly easy.
Okay, that's a compelling list. Simplicity, speed, concurrency, tooling, standard library, cross-platform. It really does sound like they thought about the developer experience.
I think that's fair to say, yeah.
So where does this all come together? Where do we actually see Go being used most effectively in the real world?
It really shines where performance, concurrency, and scalability are critical. Cloud infrastructure is probably the poster child.
Like what specific tools?
Well, the big ones. Kubernetes, Docker, Terraform, foundational pieces of the modern cloud stack, all written in Go.
Wow, okay. That's significant.
Hugely significant. It's also very popular for web backends and APIs. Its efficiency is great for handling high traffic loads.
Makes sense. What else?
DevOps tooling is another big area. Go's ability to produce single, static binaries that run anywhere makes it perfect for command line tools.
Portable and fast CLIs. Nice.
Yeah. And its concurrency model makes it a natural fit for distributed systems and microservices, building systems that need to scale out and communicate effectively.
Right, coordinating lots of small services.
Exactly. And finally, networking tools, proxies, that sort of thing. Anywhere network performance is key, Go is often a strong candidate.
So yeah, from the absolute foundations like Kubernetes up to back-end services and tooling, Go has definitely carved out a major niche.
It really has.
But, no language is perfect. There are always trade-offs. What are some of the commonly cited downsides or criticisms of Go?
That's a really important point. Historically, a big one was the lack of generics.
Which they added relatively recently, right?
They did in version 1.18. But before that, the absence of generics meant developers sometimes had to write more boilerplate code, often duplicating logic for different data types, or rely on interface, which sacrifices some static type safety.
So more repetition or less type checking at compile time?
Kind of, yeah. It could lead to more runtime checks or less abstract code. Another point some developers raise is the intentional minimalism itself.
The lack of certain features.
Right. Things like exceptions for error handling, traditional inheritance like in Java or C++, operator overloading. Go deliberately leaves these out.
Why? To keep it simple.
Primarily, yes.
Yeah.
But for developers coming from languages that heavily use those features, it can feel restrictive, maybe less expressive initially.
I can see that, like missing a tool you're used to having.
Exactly. And related to exceptions is Go's error handling style.
How does that work?
It strongly favors explicitly checking for error values returned from functions, usually with if error dig null.
Okay, so you check errors right where they might happen.
Yes, which promotes very robust, predictable code. You can't easily ignore an error, but it can also lead to more verbose code compared to, say, try-catch blocks, lots of repetitive if-error, null checks.
Right. I've seen Go code snippets like that. It can look a bit noisy sometimes.
It can, yeah. It's a trade-off between explicitness and conciseness. And one last thing to clarify. Go isn't really designed for GUIs or front-end web development.
Not for building the user interface part of desktop apps or websites.
Correct. Its strengths are firmly in the back end, infrastructure systems programming space. You wouldn't typically choose it for building a graphical application.
Okay, so it has a clear focus. Server-side, infrastructure. Good to know its limitations, too. So, looking ahead now, 2025 and beyond, as the source hints, what's the trajectory for Go?
Well, like you said, adding generics was a huge milestone. It addressed a major piece of long-standing feedback.
Did it change the language fundamentally or just enhance it?
More enhanced, I'd say. The core philosophy is still there, but it definitely makes certain kinds of code easier to write and more reusable. Beyond that, the ecosystem just keeps growing. More libraries, more tools, more community support.
And its position in the cloud-native world?
Seems incredibly solid. It's really become a staple language for microservices, for infrastructure automation, for anything needing high concurrency and decent performance without the complexity of C++wise.
Used by big tech and startups alike.
Absolutely. Both rely on it heavily for critical systems. It's sort of proven itself in production at massive scale. So its future in those domains looks very bright.
It really sounds like it's cemented its place. Okay, so let's bring it back to the listener. Someone out there is thinking, should I learn Go? Is it right for me? What guidance can we offer?
Yeah, good question. Based on everything we've discussed, Go seems particularly valuable if you're working on or interested in cloud infrastructure.
Kubernetes, Docker, Terraform ecosystems.
Exactly. Or if you're building microservices or scalable backend APIs, it's really well suited for that.
What about the learning curve?
It's generally considered relatively easy to pick up, especially compared to C++ or even Java sometimes because of that simpler syntax. So if you're looking for a language that's approachable but still powerful and performant,
Go could be a good fit.
definitely. Also, anyone interested specifically in high-performance networking tools or back-end systems should take a close look.
And DevOps folks.
Oh, absolutely. If you need to write cross-platform CLI tools that are fast and easy to distribute as single binaries, Go is an outstanding choice. Really practical.
So if your work or interests touch on cloud, backend, high-performance networking, or DevOps tooling, Go is probably worth investigating.
I'd say so, yes. It offers a compelling set of features for those areas.
Okay, great. So as we wrap up this deep dive, what's the single most important thing you think people should take away about Go? The core message.
I think the key takeaway is that Go's real strength comes from its power through simplicity. It wasn't designed by accident. It was crafted to solve specific real-world problems around scale and concurrency.
And it does that without getting overly complicated.
Precisely. It doesn't try to be everything to everyone. It's not the language you'd pick for every single task out there. But for its chosen domain-building, reliable, scalable infrastructure and back-end systems, it excels.
So that intentional simplicity isn't a weakness. It's actually its core advantage in those contexts.
That's a perfect way to put it. If you need to build those kinds of systems without getting totally bogged down in complexity, Go's approach is, well, pretty powerful.
That really clarifies its position. It's certainly given me a much better handle on why Go is such a force, especially in the cloud world.
Well,
And maybe, like the source hinted, we can tackle some other big languages like Python or Rust in a future deep dive.
that would be interesting too. Lots to explore there.
Definitely. But for now, for anyone listening who's thinking about Go, I guess the advice is keep your goroutines lightweight and your code clean.
Sounds about right.
Thanks for joining us on the deep dive.